Hello, myself Ayush Rajendra Chavan. My roll number is 4160, and I am going to give a presentation on logical clocks in the distributed cloud computing. So, how time works in the cloud? The distributed cloud system, by their nature, involves multiple independent computing nodes operating asynchronously across a network, ensuring accurate event ordering and consistent state across the disparate components of fundamental challenges, especially when dealing with the shared data and concurrent operations. uh, Precise synchronization is crucial for the reliability, data consistency, and debugging in complex distributed environments. So, what are the real challenges in the physical time? So, first one is a clock skew, then relativity, network latency. What is a clock skew? It is a physical clock on a different machines drift due to the hardware imperfection and environmental factors. Even with the NTP, perfection synchronization is impossible. So, in relativity, Einstein theory dedicates the true global time in a fallacy events observed from the different reference frames can have different ordering. That means different frames of a different global network can have a different ordering with respect to the each process has a different times in different time zones. To overcome this, we use the logical clock. And what is the network latency? The message takes variable time to travel across the network, making it difficult to establish a precise temporal relationship between the events on a different node based solely on a local time span. That means we know that as the time span is not constant all over the world, it changes uh, based on the day and night schedule. So to overcome this, and also we need to consider the network latency. Our network latency varies between 0 to 1. That means if the network is super fast, it will have the latency of 1. So what is the logical clocks? Logical clocks provides an alternative to the physical time for ordering the events in the distributed systems. Instead of tracking exact time, they track the causal relationship between events. Okay. Then they track the time span or the time gap between the events to overcome the time difference. Causality is focused. Causality is focused relative ordering and simplicity. These are the three main features of the logical clock. The capture happened. What is the causality focused? The capture happened before relationship, crucial for maintaining consistency without relying on the synchronized physical clock. Then what is the relative ordering? The relative ordering means the logical clocks establish a partial ordering of events, where if event A casually affects the event B, then A always happens before B. Then what is the simplicity? They are simple to implement than the complex time synchronization protocols, and are more robust to network delays and the clock drift. Then what is the Lamport's logical clock? It is the proposed by the Leslie Lamport. This is the simplest form of the logical clock. Each process maintains a local counter. That means interval. There are the three main subparts in that. That those are internal event, sending message, and the receiving message. Internal event keeps on incrementing the counter. Then the sending message increment the counter. Then sends the message with the timestamp. Then receiving message increment the counter to the max local counter message times time plus 1. That means it increase time span by 1 to cope up with the increasing time at the sender side. The same follows for the receiver side. This ensures that if the event A happens before event B, then the clock value of the A is less than the clock value of the B, where the C is the logical clock value. However, the converse is not always true. Vector's clock beyond partial ordering. This is the second form of the clock in which there are the concurrency. So which kind of concurrency? Addressing concurrency. Unlike Lamport clock, vector clock can detect the concurrency. Each process maintains a vector of integers with one entry for the every process in the system. That means each process maintains a vector of integer. Each process has its own integer value with entry for every process in the system. Then what is the mechanism in it? In it there will be the three parts: internal event, sending message, and receiving message. Internal events increment its own entry in the vector. Sending message sends current vector with the message. Receiving message updates its vector by taking the element wise maximum of its current vector, and receive vector then increment its own entry. So what is the advantages? Then that means the clock value of the a will be the less than the clock value of the b element wise as we compared. Then a happens before b. If neither it's true, then the a and b are concurrent. That means if this condition remains false, then a and b should be concurrent. Then the applications and the limitations in the cloud environments. So the applications of the logical clock are casual consistency in the database. The database should be consistent. That means the result should be reflected in the database. Distributed debugging and the trace analysis. Then conflict resolution in eventually consistent system. Replica synchronization and data versioning. So what are the limitations? Vector clock required knowing that the total number of the processes which is dynamic in the cloud environment. Vector size can grow with the number of the processes, increasing the message overhead. Logical clocks do not guarantee the real-time ordering, only casual ordering. So what are the future trends and the key takeaways? Key takeaways: logical clocks are indispensable for managing the casualty in the distributed cloud systems, offering the robust solution where the physical clocks fall short. So there are the three terms: hybrid logical clocks, blockchain and DLTs, global scale computing. So what is the hybrid logical clocks? Combine casual ordering of the logical clocks with the real-time approximation of the physical clocks. That means, as we know, the logical clocks doesn't work on the physical clocks. It works on the casual ordering of the time. So it combines the logical clock with the real-time approximation to cope up with the physical clock. So what is a blockchain and DLTs? What will be the future trends in the blockchain and DLTs? These will be the new distributed leaders technologies. Like the blockchain leverage casual ordering for tampered proof transaction logs, expanding the scope of the logical clock application. Then the global scale computing. If we need to globalize the cloud environment, for that we need to use the logical clocks. As a cloud environment becomes the increasingly global and the complex, sophisticated logical clocks mechanism will be even more critical for the reliability and the performance. So these are the some features, advantages, and types of the logical clock.